dissipation of heat through convection. That means the oil moves within the tank. But when sludges are formed, since they are very thick and heavier, they cannot move within the transformer tank. And what happens, they usually deposit themselves somewhere on the insulated coils. What happens, where they deposit, their liquid oil does not come in contact with the conductor, I mean insulated conductor though, and does not take away the heat continuously being generated at that point where it has been deposited. So from elsewhere, the heat is being dissipated because of the movement of the oil. That's the process of convection, through the process of convection. But there, where sludges have been deposited, heat is not being taken away or dissipated. So locally temperature rises. And ultimately, you know about class of insulation. Class of insulation is how much temperature it can withstand. So once the temperature exceeds that withstandability, the solid insulation on the conductors of the transformer coil, they get charred. No longer they can insulate. So with even less insulation, there is shorting of certain coils or turns. So even increased amount of current flows, more heat is generated. Ultimately, what happened? Tremendous pressure is created within transformer tank. It explodes. If nearby there are human beings, there have been several occasions when they died. So we always have to keep a check on the quality of the oil, whether sludges have been formed, whether too much contaminating particle is within the oil. From time to time, you have to test. And this test setup is for testing the quality of the oil. So what exactly does it measure to ensure that the quality of the oil is good enough for use as a liquid insulant in any transformer? In this test, we actually test the electric strength. Electric strength in physics or in field theory, electric strength is the field intensity which an insulating material can withstand. Field intensity's unit is kV per centimeter or kV per meter. But we do not, in this experiment, we do not measure the field intensity. We do not measure the field intensity. We cannot measure. We don't have the technology for that. What we do is that we just see in a fixed setup how much voltage difference between two electrodes. দেখো ওখানে একটা সার্কিট ডায়াগ্রাম রয়েছে, একটা টেস্ট সেল রয়েছে, সেখানে সমস্ত ডাইমেনশন ফিক্সড। টেস্ট সেলে what will be the depth of oil, at what depth from the surface the electrodes are there, what is the diameter of an electrode, how much gaps should be there within the electrode. Once all these dimensions are fixed, for a certain potential difference within the cell, at any specific point, the field intensity is fixed. So, as we increase the potential difference between the two electrodes, at every point, the field intensity is rising. At a certain potential difference, as we go on increasing the potential difference, at a certain point of time, the field intensity, where it is the maximum within the cell, exceeds the withstandability of the dielectric, the breakdown strength of the oil, and what happens is that the oil breaks down there. At that point, in a very small area or space, but as it breaks down, tremendous heat is generated that decomposes the organic oil material. So many conducting carbon particles starts to exist within the gap. They form a chain of conducting particle between the two electrodes. So these conducting particles, they actually start carrying extra amount of current. So more heat is generated. And ultimately what happens, the entire gap between the two electrodes, gap filled with oil, it breaks down. So as you go on increasing the voltage, at a certain point, you will see that there is a breakdown. When the breakdown takes place, tremendous amount of the oil was acting as the insulant. So little amount of leakage current was flowing. Now as the breakdown takes place, the oil is no longer acting as an insulant. So the entire supply is short-circuited. Tremendous amount of current is drawn by the cell. So the overcurrent relay senses it and it trips the supply voltage. So 6 times we'll conduct the same thing. We'll slowly, with a rate of 2 kilovolts per second, we'll slowly raise the voltage till automatically the set trips. And we'll keep an eye on the voltmeter in the circuit. We'll just record the voltmeter reading at the point of the tripping. So that is the breakdown voltage. What was the breakdown field intensity at which the oil broke down? We cannot measure. But that's not required because it is an industrial practice. What we need is a qualitative measure or qualitative assessment of the quality of the oil. So if it breaks down at a higher voltage, safely higher voltage, the oil condition is good. If at a much lesser voltage it breaks down, that means the oil is not fit for use as an insulant. So that decides whether the oil passes the test or it does not pass the test. So there is a standard voltage difference between the two electrodes. If it is exceeded before the breakdown takes place, it means the oil quality is good. It passes the test. If it is below that voltage, the oil fails the test. So we are not going to provide any certificate to anybody. We are just conducting the experiment. We'll just record at what voltage the breakdown takes place. And 6 times we'll repeat the same procedure, and 6 times we'll record the voltage at which the breakdown takes place. They will not be identical voltages. Very near values will be there, but slight differences will be there. And the average of these 6 voltages is the breakdown voltage of the for that sample of oil. We can always replace the a certain oil sample, filling the cell, and to conduct a test on a different sample, we then fill up the cell again with a different sample of oil. So we can carry out tests on different samples, but for every sample, 6 times we'll raise the voltage slowly at a uniform rate of 2 kilovolts per second, but then the average of the 6 breakdown voltages recorded will give you the breakdown voltage for that particular oil sample. That is all about our experiment. One thing we have to do always is that since the cell is made of perspex is a material which is transparent, and the cell is illuminated by a bulb from below. You can always locate if there is any air bubble in the oil. Now, air bubble we cannot allow to be within the oil. That you can intuitively guess that we cannot allow anything other than pure oil. Even air bubbles are not allowed. The measure that is taken is that we dip a glass rod to touch the air bubble. The moment the glass rod touches the air bubble just along the surface of the glass rod comes up and comes out of the oil surface. So the air bubble is thus removed. Why the air bubble is necessarily removed? Two things you have to remember. The electric field set up because of the voltage difference between the two electrodes has a certain flux distribution. At any point, the field intensity E is related to the flux density at that point by a relationship. Can anyone remember what is the relationship between the flux density and the field intensity at a certain point? Can anybody tell me?
Field intensity is equal to 4.44 into frequency into number of turns into
এটা কোথায় আছে? এটা
flux
কোথায় আছে?
density.
এটা কোথায় আছে?
এটা স্যার হচ্ছে
হ্যাঁ?
ওই ট্রান্সফরমারের ওই যে কোর ম্যাটেরিয়াল
ট্রান্সফরমারের এটা আমরা করছি না, আমরা অয়েল একটা ডাইইলেকট্রিকের ভেতরে করছি। ডাইইলেকট্রিকের ভেতরে ফিল্ড ইন্টেন্সিটি আর ফ্লাক্স ডেন্সিটির মধ্যে সম্পর্ক কি?
ফ্লাক্স ডেন্সিটি হচ্ছে পারমিয়াবিলিটি টাইমস ইন্টেন্সিটি।
একটু জোরে বলো, আমি শুনতে পাচ্ছি না। কে সম্মোদিত বলছো?
স্যার পারমিয়াবিলিটি টাইমস।
পরিষ্কার করে জোরে বলো, আমি শুনতে পাচ্ছি না।
স্যার ফিল্ড ফ্লাক্স ডেন্সিটি হচ্ছে পারমিয়াবিলিটি টাইমস
পারমিয়েবিলিটি নয়, পারমিয়েবিলিটি নয়। পারমিয়েবিলিটি ম্যাগনেটিক মেটেরিয়ালের ক্ষেত্রে, ডাইইলেকট্রিক মেটেরিয়ালের ক্ষেত্রে কি? কে জানে? যেটা পারমিয়েবিলিটি ইন কেস অফ ম্যাগনেটিক মেটেরিয়াল, ইন কেস অফ ডাইইলেকট্রিক মেটেরিয়াল, ওটাকে কি বলে? এটা স্কুলে পড়ানো হয়েছে, মাধ্যমিকে পড়ানো হয়েছে। Anyway, you take care of yourselves. It is called permittivity and usually denoted by epsilon. So flux density is equal to epsilon E. E is field intensity. That means E, the field intensity, is equal to D divided by epsilon. So if the flux density, flux distribution will be identical for any specific voltage difference. That means D is identical, but what is the permittivity at that point will decide how much will be the field intensity. Now, since in an air bubble, the permittivity will be much less, for the same flux density, the field intensity will be much higher. Since it is much higher, there will be breakdown within the bubble. And any breakdown raises the temperature, any breakdown decomposes the oil, any breakdown creates free particle within the oil, and it hastens, it actually makes the breakdown quicker at a lesser voltage. So maybe the oil quality is good, but just because there was a bubble, at a lesser voltage breakdown takes place, and we consider that the oil sample was not good enough. That will be an erroneous result. So that's why bubbles are replaced. So this is all about how to conduct the experiment, about the setup and what kind of a circuit really supplies the voltage difference between the two electrodes is given in the subsequent figure. Can you see the subsequent figure? I have sent yesterday itself. The circuit diagram, can you see?
Yes, sir.
Now, at the extreme right hand, there is there is a rectangle within which there are two small circles facing each other. Can you see? Just see the circuit diagram. At the extreme right, there is a rectangle. Within that, there are two circles very close to each other with a small gap between them. That is the sphere gap. Okay. So the voltage is provided through a transformer. The transformer on the primary will have at the most a voltage of 230 volts, but at the secondary it can be up to 100 kV. Now the secondary is tapped and arched. Can you guess why? Because if it is tapped and arched, that means the midpoint will be at 0. For a 100 kV potential difference between two ends, one end can be at positive plus 50 kV, one end can be at minus 50 kV, so that total potential difference will be 100 kV. That means any of the terminals will not be having a potential more than 50 kV. So we can arrange an insulation for any of the terminals which is capable of withstanding 50 kV. But if, just guess, try to imagine, if one end of the transformer winding, secondary winding, is arched, then that end will be permanently at 0 potential and the other end will be, for a potential difference of 100 kV, the other end will be at 100 kV. So you have to provide an insulation of 100 kV. 100 kV insulation is a huge insulation, but 50 kV insulations are much smaller insulations and much cheaper as well. So that's why for a space economy and from the cost of insulation to be provided, it's a better practice to tap the center and arc it. There are, as we go towards the left side, you see there are two switches on the same spindle. That means they always make themselves on or off together, and they will be on when a current flows through the contactor coil. Just below that, there is a cylinder kind of thing, contactor coil. So to give the potential difference, to provide a potential difference, the circuit must be in on state, and for on state, the circuit to be on, the contactor coil must carry some current. The contactor coil can carry current, but there are so many switches in series with it. You can see the circuit diagram. If all these switches are on, then only contactor coil can carry some current and the main circuit can be in on position and the potential difference can be applied between the sphere gap. But how to vary the potential difference between the sphere gap? That is about the top horizontal line on which there is overcurrent relay, you can see. That point is movable. If it is at the topmost position, it means the total coil, the supply coil voltage is being impressed upon the circuit. If it is at the lowermost point, that means the total coil is cut out from the circuit, so it is 0 potential across the transformer primary. In between any position will accordingly proportionally provide a part of the voltage, that is 230 volts. So from the lowermost point, moving it towards the uppermost point will slowly increase the primary voltage. That is how the voltage is changed. And there is a certain switch arrangement which always ensures that once there is a tripping, unless you bring down the connection to the lowermost point, that is, again, you bring down the supply voltage to 0, the supply cannot be made on. The contactor coil will not carry any current. It is to ensure that always the potential application happens from 0 onward, upward, not from 10 kV or from 20 kV or from 30 kV, always from 0 upwards, say up to 45 kV or 50 kV, at whatever voltage the oil breaks down. So that is all about the circuit. And there is a case of questionnaire. You have to answer all of them. If you have any question, ask me. You have to write the answer to those questions. You have to prepare yourself for them. The amount of data that you need as the experimental data, do you know where to get it from? জানো কোত্থেকে ডেটাটা পাবে? সিআর কোথায়?
নো স্যার।
তাহলে কি করে এক্সপেরিমেন্ট করবে? তাহলে রিপোর্টটা জমা দেবে কি করে? তোমরা বাড়িতে বসে থাকবে আর তোমাদের দিয়ে সবাই রিপোর্ট আমরা এই হাতে লিখে জমা দিয়ে দেবো, এই হবে নাকি? তোমাদেরকে জেনে শুনে তো ডিসাইড করতে হবে যে কি করে কি করবে। বসে থাকলে ডিগ্রি যে কেউ দিয়ে দেবে, এই ডিগ্রিতে কোনো চাকরি দেবে না, ওই জোম্যাটো আর সুইগির ডেলিভারি বয় হতে হবে। কখনো মাথায় আসেনি যে এক্সপেরিমেন্টটা তো স্যার কম্পিউটারে বা ফোনে করে দেবেন না, তাহলে ডেটাটা আসবে কোত্থেকে? কি করবে তাহলে? এটা কি তোমাদের প্রথম এক্সপেরিমেন্ট নাকি? উত্তর দিচ্ছ না কেন? এটা কি প্রথম এক্সপেরিমেন্ট?
স্যার সোফার আমাদের অন্য টিচাররা ডেটা প্রোভাইড করে দিয়েছিলেন এই ক্লাসটা হওয়ার পরে।
ডেটা প্রোভাইড করে দিয়েছিলেন?
হ্যাঁ, আমরা যেহেতু এখন এক্সপেরিমেন্ট নিজেরা করতে পারছি না, আমাদের মানে একটা লিস্ট অফ ডেটা যেটা আসার কথা সেই রকম একখানা দিয়ে দিয়েছিলেন, সেটার উপর
তাহলে
রিপোর্ট
আমি
লিখতে
যে
বলেছে।
ফর্মটা পাঠিয়েছি আর যে ফাইলটা পাঠিয়েছি এর মধ্যে আছে? দেখো যে ফাইলটা আমি অ্যাটাচ করে পাঠিয়েছি।
হ্যাঁ স্যার, ব্রেকডাউন ভোল্টেজের ডেটাগুলো রয়েছে।
রয়েছে?
হ্যাঁ স্যার।
তাহলে ঠিক আছে, তাহলে ওইটা ইউজ করে দেবো। ফাইন, তাহলে একমাত্র রইলো ওই রিপোর্ট করতে গেলে যেগুলো the answer to certain questions you must be aware of, সেগুলো নিয়ে যদি কোনো প্রশ্ন থাকে আমাকে করো।
Sir, comment on the quality part.
বলো।
Comment on the quality যে পার্টটা রয়েছে, তো
একটু জোরে বলো, অত আস্তে বললে কিচ্ছু হবে না, মিনমিন করে বললে হবে না, জাস্ট শাউট।
স্যার বলছিলাম যে কমেন্ট অন দ্য কোয়ালিটি অফ ট্রান্সফরমার অয়েল যেটা রয়েছে, তো
শুনতে পাচ্ছি না, জোরে জোরে জোরে। এক সেকেন্ড দাঁড়াও, আমি হয়তো সাউন্ডটা বাড়ানোর চেষ্টা করছি। দাঁড়াও তো, আমি হেডফোন লাগিয়ে নিই, নাহলে শুনতে পাচ্ছি না। হ্যাঁ, এবার বলো। হ্যালো, কে বলছিলে? সৌম্যদীপ বলছিলে?
হ্যাঁ স্যার, বলছিলাম যে কোয়ালিটি অফ দ্য ট্রান্সফরমার অয়েল যেটা রয়েছে, তো সেটা কি একটুখানি বলতে স্যার, কি মানে কি হিসাবে?
বললাম তো প্রথমে শুরুতেই তো সেটা বলেছি, ইট মাস্ট বি স্লাজ ফ্রি, ইট মাস্ট বি ফ্রি অফ কন্টামিনেটিং পার্টিকলস। কেন সেটা দরকার সেটাও বলে দিলাম। আচ্ছা, বিদীপ্ত 33 জনের রোল নাম্বার আমাকে লিখে একটু কিছুক্ষণের মধ্যে পাঠিয়ে দাও, মানে উইদিন 4:30।
স্যার আমি যারা প্রেজেন্ট তাদের পি মার্ক করে আপনাকে পাঠিয়ে দেবো।
তাদের কি মার্ক করে
প্রেজেন্ট মার্ক করে পাঠিয়ে দিয়েছি।
দিয়েছ?
ইয়েস স্যার।
ওই হোয়াটসঅ্যাপে পাঠিয়েছো?
ইয়েস স্যার।
আচ্ছা ঠিক আছে, ফাইন। ওকে, দেন দিস ফার অনলি। দুজনকে আমি ঢুকতে দেইনি বিকজ দে জাস্ট রিপোর্টেড অ্যাট দ্য এন্ড অফ ইট। ফাইন, থ্যাংক ইউ ভেরি মাচ।